Hello guys, welcome back to our one and only channel Apna Tutors. Okay, so what were we doing in the previous videos? We were doing chapter 1 relations and functions. This chapter is quite easy, right? Till now you would have got that this chapter is quite easy. But still you should understand this basics very well because it will help you a lot in the higher studies. As I have studied from IIT, I can tell you that professors are very keen for the basics. Okay, so without wasting much time, let's move forward. So in this video we will do more questions from the exercise 1.1. okay, so till last video we had covered till question 6. So let's start with the question 7. So what is question 7? So that the relation R in the set A of all books in the library of a college given by relation is given as containing pair x comma y such that x and y have same number of pages. We have to show this relation is an equivalence relation. Again, same process. For equivalence relation you will have to show reflexive, symmetric and transitive. That's all. So okay, without wasting, let's do what we'll do. First we will have to show reflexive, right? Let's today write with some different pen. Reflexive. Okay, into color, let's pick blue today. Okay, so reflexive. For reflexive, what we'll have to show? We'll have to show that for every x belongs to set A, that is our universal set, which is set of all books in a library college, we should have x comma x should be in R. Now since x is any book, and when x comma x will belongs to R, when this will happen? When x and x have same number of pages, have same number of pages. This is true, right? As x and x are same book, so of course they will have same number of pages. So it holds that for every x belongs to A, will have x comma x belongs to R, which shows that a relation is reflexive. This is what definition of reflexive. This is what we are doing from last few videos. Okay, so next is symmetric. For symmetric, what we'll have to show? That if xy, for every xy belongs to R, yx should also belongs to R. So for every xy belongs to R, this will implies that, what does this mean? Xy belongs to R. This will means that x and y have same number of pages, but this also means that y and x have same number of pages, right? Because this is same thing. So y and x have same number of pages, that means y and x belongs to R, because that is what definition of R given, that y comma x belongs to R when y and x will have same number of pages. So we are done with symmetric. Let's move to last part, transitive. That is also very easy. That suppose for every, we have to show for every xy comma yz belongs to R, we'll have to show xz will belongs to R. So let's pick some arbitrary xy and yz belongs to R. Arbitrary in the sense that we are picking any randomly. We are picking any xy yz from R. So that if we are showing for the any randomly, that means we are showing for every pair, right? Okay, so what does this mean? This will mean that first of all, x and y belongs to R will mean that x and y have same number of pages. You write all the things. Y and yz belongs to R will means y and z will have same number of pages. Now x and y have same number of pages and y and z have same number of pages, but this also means that X and Z have same number of pages, right? So this will imply XZ will belongs to R, because this is what definition of R. So we are done, right? We have shown that it is reflexive, then we have shown it is symmetric, and now we had shown it is transitive. So we are done, because for equivalence we needed to show reflexive, symmetric and transitive. Okay, so we are done with this question. Let's move to next question. So what is given in this question? In this question we are given one relation R on the set A. Universal set is this 1 2 3 4 5, having element 1 2 3 4 5, and the relation is defined as pair A comma B such that modulus of A minus B is even. I think you would have studied about modulus, right? What modulus do? It gives positive sign of any element. That is, if I pick x equals to -2, then what will be mod of x? It will be 2, because positive sign of 2 -2 will be 2. Are you getting it right? What I am trying to say by positive sign of -2? Yeah, I am speaking very loosely, but this is what I mean, that positive side of -2. Okay. So how relation is defined? Having pair A comma B such that modulus of A minus B is even. We have to show this is equivalence relation. First let's show that it is equivalence relation, then we'll do further question. Okay, so for equivalence again we'll have to show reflexive, symmetric and transitive. First let's show reflexive. So for reflexive we have to show for every A belongs to A comma A should belongs to R. So whether this holds or not we have to see. So let A belongs to A. Now what will be modulus of A minus A? A minus A will be 0, and modulus of 0 will be, because sign of 0 is already positive. We always take sign of 0 as positive. Okay, we don't say -0. So it is 0 only. And we know that 0 is even number. So we got that A minus A is even. And this is what definition of relation is, right? So we got A comma A belongs to R. When we'll say A comma A will belongs to R? If modulus of A minus A is even. So we got it as even, right? So we got that relation is reflective because we had arbitrary picked any element. Okay, now let's show symmetric. Next is symmetric. Let, for that again, let AB belongs to R. What does this mean? That modulus of A minus B is even. What does this mean? Modulus of A minus B is even. That is, we are taking positive sign of A minus B and that number is even. But the sign matters when we are telling about even. It doesn't matter, right? Even is what? Just 2 times, like two times multiple of any numbers is called even numbers, right? So sign doesn't matter. Hence, modulus will not matter much. Still, let's do it mathematical. Let's see how we'll show it mathematically. So we have to now show that BA also belongs to R. Then only we can say, right, that our relation is symmetric. So A minus B is even. Can I write this as -1 into B minus A? Right. I did nothing, just had taken out -1 common. Now you know the property of modulus, that the modulus of A into B, modulus of A into B is same as modulus of A into modulus of B, right? You should know this property. I think you would have studied in 11th class about this modulus function. Okay, so modulus of this will be modulus of -1 into modulus of B minus A is even, because this was even and this is same as this, right? Because modulus of -1 into B minus A is same as modulus of -1 into modulus of B minus A. Now modulus of -1 will be positive sign of -1 will be 1. So 1 into something is something. So modulus of b minus 1. A is even. Are we done? Yes, we are done, because this means that b comma a belongs to R. So we had shown that it is symmetric. Now let's move to transitive part. Third is transitive. So for transitive, we'll have to let a comma b belongs to R, b comma c belongs to R. What does this mean? That modulus of a minus b is even and modulus of b minus c is even. What we have to show? I always forget to write what we have to show. We have to show a comma c belongs to R. What does this mean? When can we say that a comma c will belongs to R? If we show that the modulus of a minus c is even, then we are done, right? If modulus of a minus c is even, then that means a comma c belongs to R. Here I am writing reverse implication, because if I show this, then that will mean this. Okay, so let's move for that part. I have to show modulus of a minus c is even, right? Can I write modulus of a? I will have to use something for this, right? A minus modulus of a minus b and modulus of b minus c. I will have to use something about that. So let's try to write it like this, something like this. If I write it like a minus b minus of b minus c, is this correct? I don't think it is correct. Wait, have I did something mistake? Minus b, and here should I have, if I am writing minus b here, minus b should cancel out, right? B comma c belongs to R. Okay, so that will means is this part. Okay. A minus b plus c minus, okay, not plus, minus c minus b. Now is correct, right? Because minus c plus b, b minus b plus b will cancel out, and we will remain with mod of a minus c. Now this part is even. This part is even. That is because mod of a minus b is even. That will also means that. What will this? This means that before this step you should write this step. Let me write it only. This will means that a minus b is even, right? Because what is modulus of a minus b? It is nothing, just we are checking with sign, but sign doesn't matter when we are writing even and odd, and this also means b minus c is even. So this means that a minus c, which how I had wrote that a minus b plus, not plus, minus c minus b. Now this part is even, this part is even, and this part is also even, because b minus c is even, then c minus b will also be even. So now subtraction of two even number will be even. Thus we can say a minus c is even. This will imply modulus of a minus c is even, right? That is what we wanted, right? Modulus of a minus c is even. So we are done. We had shown reflexive, then we had shown symmetric, now we had shown that it is transitive. So we had got that the relation is equivalence. Now let's see what is the further part of the question. So further we have to show that, now I think further part you will do it by your own. I will give you as a homework still, but I will give you idea how to do it, so that all the elements of 1, 3, 5 are related to each other, and all the elements of set 2, 4 are related to each other, but no element of 1, 3, 5 is related to any element of 2, 4. Okay, so what is this saying? That in this set every elements are related. Let me name this as says little a. So in little a set every elements are related. What does this mean? That means you have to take every two pairs in this, every possible two pairs in this set, and then you have to see that whether it's subtraction. That is, if you are taking any two pairs, suppose 1, 3, then you have to see whether mod of 3 or mod of 1 minus 3 is even or not. That is easy because every numbers are odd, so the subtraction will be of course even. And similarly, subtraction of even is even. So here also, let me name this as a little b. Then in little b set you will also have that every elements are related to each other, but then they are saying no element of this little a is related to little b. Why? Because suppose one element you pick from little a, that means it is odd, and one element you pick from little b, that means that is even. So of course subtraction of odd and even will be odd. That means that modulus of a minus b will be odd. That means it will not be related. So it is easy, right? So you do it as at homework. Yeah, so we are done with this, right? So let's keep till here today for the today's video, or in fact this video. I can upload more also. Okay, so that's it. Have a good day. Thank you.